Okay, this is a video for the assembly of the project and also a little bit on the drafting part. So we're going to put all the parts together. Something uh, will be looking like this, and that's the transparent turn on. All right. So anyway, let's start with our parts. So there's no slides for this. The closest thing is the lab slides for assembly and drafting. So if you have questions or if you have difficulty on the assembly, you can take a look on this slides. All right, so let's close that, and before you start, you want to put all the parts in one folder, and then the assembly file can also, you want to put that in this folder. Otherwise, once you open the assembly, you will not be able to find your parts. So you want to save your assembly in the same folder as where the parts are. So let's build a new assembly. That is assembly file. The same units, just in case somehow you use the millimeter, stay with the units you're using. So assembly, and I want to save to the same folder, and my parts are here. So I'll put that in this folder. And you notice the name is .prt. So you want to have the file name that you know it's an assembly, not a part, because the modeling is the same. It's .prt. So we'll start. Okay, when you start, it'll ask you to add components, and nothing is loaded. If you have anything open, then you will have some parts here. So we'll open the parts. Okay, then we can start from the biggest part, the jaw handle, or the handle. Yeah, jaw handle is better. So that's a little preview of the part, and you can choose to place this on the absolute origin, or you can use some other method. Sometimes you can use by constraint. If you want to put a pin in a hole, you can use by constraint. So absolute origin, that is good. All right. Now that'll put your part's origin coincident with this assembly origin, which is right here. Then next, so this part is not fixed yet. This part has 6 degrees of freedom. If you show degree of freedom, it can move any directions. But what we will do is first we will fix this. There's a assembly constraint. We'll use a fixed constraint and fix this. So this one will not move. Now every other parts will be added onto this part, and in this case, your whole assembly will have an anchor point in this space. Otherwise, this can go floating, and you move one part, everything will move. Okay. Now we can keep adding components. So add components, and open a folder. We'll add. Let's see what we should add. So those little pieces are in another handle, and the other handle has nothing to do with this handle. So we might need to put this jaw in first. Okay, apply absolute origin, and actually you can insert a lot of stuff inside just one step, and I have some sheet body on that part, so I want to hide that thing. So let's show and hide. Now I'll hide all the sheet body. Click this. Alright, then we'll move this around. So move the components. and move this away. We'll move this. So this is flipped. Now I want to rotate, dragging this handle and 180 degrees. Okay. Then if you look at the picture of how the real thing works, okay, this jaw is actually sliding on the jaw handle, and this face, cylindrical face here, will be touching on the face here. So we'll move to a generally good position first. Then we apply a constraint to make that proper movement. So touch align constraint for this. Where's that? We might want this. Okay, so there's our cylindrical face. It look like here. Then touch to this face. Now, when you first start it, you might want to just try to move it and look what happens. So as you can see, it's not very good. Just move one axis first then. So it will move up and down. It's not gonna move on the X direction because that face is already touch constrained to the touch align, but you can move on the Z direction. Okay, those two faces are still touching. If you look from the top, okay, as you can see, this arc is still touching this line. It's just that we haven't constrained on the Z direction yet. So we need another constraint to make it centered on the jaw handle. And we do have that kind of constraint. It's called the center. And in the subtitle, we have 2. So maybe it'll tell you something here. No, okay. So 2 to 2 is it'll center 2 objects to other 2 objects. Meaning, let's say we have a pair of faces, 2 objects, right? That's symmetric. So once you pick these 2, it'll find the center of these 2 faces. Then you can select the other pair or another pair of faces, and then it'll align the center of those 2 pairs together. So that is how it centers a part. Alright, so you might want to rotate a little bit so you have a better so what's next? Next is the handle will be connected to this hole here. Right? So we need to flip this handle. Okay, I'm gonna move and rotate. Drag the point on the rotational degree of freedom. That is 180. Then I'll drag on X direction. Maybe rotate on the Z-axis a little bit more. Okay, then we'll align those 2 holes. And how to align holes together, we have a couple different options. First is touch align. We have this infer center and axis. So this one, if you hover on the cylindrical face or the circular edge, it'll show the center line. Then if you can align those 2 center lines together. So that to this. Okay, this might be the best for aligning holes because it doesn't care about how big the hole is. Even though we have the same radius here. And one other option is fit. So fit does require you to have the same radius In this case, those two holes do have the same radius, so they can be fit together. If you use fit for this to this hole, it will not work. It's red. So fit will need same radius or the same diameter. The center line you don't have to. So just for example, right? You can center those two holes. So here I'll just use the invert center and axis to move these two together, and as you might guess, it can still move on the axial direction or on the center line direction. So if you drag on Z direction, it can move out of the slot. Okay. So again, we need to use the center constraint 2 to 2, and we'll pick again those two faces centered to this pair of faces. Alright, now we can move this a little bit to open it up. Okay, then we might want to make them a little bit transparent. So right click on the parts or the components. You can edit display. Now here we have translucency. You can do, I don't know, 40–50%. Alright, then we need to put some little parts into this handle. So not that button, this button. So we have the locking block, locking knob, and a link. With those three parts, we can either do, well, we'll just insert to absolute origin to have them in the graphic window first. So we'll drag this part to some place first and apply. We'll move the other one. We don't really have to move it. We can just well, we have to take a look first because it's not symmetric. You have to be careful which side goes into the handle. Okay, so as you can see, our little parts, they all have the taller cylinder on at the bottom, and in our case, the through hole is on the top of the handle. So we need to flip all of them, all three of them. Okay. So we need to select this piece and that, and let's rotate them 180 degrees. And okay. Then we'll put this into the slot, the handle first. So we can use a constraint, which is touch line and the invert center axis. We want this axis to go into this axis. Okay, so that is the first. Then the second is the locking knob, goes into this hole here. Excuse me. And the last one is the locking block that goes into here. Okay, so this locking block, it doesn't really have anything else. In real life, you have a retention spring here with a little pin that sits in the slot, so you can, move this what do you call that, locking block. You can move this on and off, but we don't have that here. So just put this any position that looks proper, and either you can use a bond to make it not moving relative to the handle. And before we do that, you can see this on the axial direction, it's not there yet. So it's not there. Then we can do the top face should be flush with the top face of the handle. We can do a touch line and preferred touch. You can do this face to touch, make that face to touch this face. So it'll come up a little bit. Okay, and the other thing is, since this is, we can use one constraint to replace that center line and the touch. Just let's try to delete this first. So now our locking block has nothing, no constraint. We can use one constraint, which is concentric, to make this circle on the top of your locking block to be concentric to the edge of the handle. This edge to that edge. Okay, so because it's concentric, it'll pull two circles into the same plane, and also the cylindrical face will be on the same axis. So that's one constraint will take care of both of the. It's about the same effect as those two. Okay. So what's next? Next we'll put this link inside this hole here. This is a little bit tricky because it'll slide in the hole. I don't know if we can do that now. So we do a touch a line. Okay, we'll try to make this face, cylindrical face, to touch the inside of the slot. Okay, and you might say, not why it's not in the slot. It is touching this inner face of the slot, but it considers that face, extended all the way to there. So we might need another one. We'll keep it that way first, but we can move this down a little bit, so you can see it is indeed sliding inside this block. I mean the slot. So what we need to do now is we need to find a position to fix this movement. So say I want this to stay here. We can use a distance constraint from center line to that center line, and you can define the distance as you wish. And remember, this is not motion analysis, so we can't really do, say, okay, we want to squeeze it to see how this slides in the slot. That's something else. It's called motion simulation, and that is out of this class. So if you want to do motion, you might need to spend some time on that application. Okay, so here we just put things in a proper position. So as to this one, we might need to move it a little bit. Okay. And lastly, we're still missing one part. It's the sliding block. So those gears engage another part, which is the first part we made, if I remember right. That's this one. And we'll insert to absolute origin here. And first, let's rotate 180 degrees. Okay. And it slides on the back of the jaw handle, so that is a touch. We'll just apply a touch with that too. Okay, then we can move this down a little bit. Then it will engage the gear on the handle, and if you notice, it's not centered yet. So before we engage the gears, we need to do a center constraint. Make this 2 faces, center to that 2 faces, and usually those pairs of faces should be parallel to each other. Okay. So now that is centered, we want to engage the gear. So it's not perfectly aligned, so there's really need to play the trick a little bit. So let's hide the jaw first. Now we can see things. So let's say, because there are so many faces here, we can only really keep up one pair of faces touching all the time. So this way it'll stay on the, they're gonna stay, and they might eat into each other, you know, and because in real life the engaging point will change, okay, as the angle changes. So here we really can't do that. We'll just get one face to touch. And which one is the better one? If we can do this piece, touching that piece. Okay, it's not perfect, but let's try to move the handle. So now at least this stays on relatively realistically. Okay, and then you notice this jump up and down because the 0.1 inch could be up and down out of this center line. So what we can do is we might want to force it down first. And we can go back, cancel that movement, and let's say, what can we do to make it? So we can add another distance constraint from the center line of that cylindrical face to the center line of this cylindrical face. Okay, so that is center line here, and don't change this number, just keep it, then it should stay there, it will not move. So it's a little bit better. Next time you change the distance, you need to change both sides. Okay. All right, then what next? Actually, we're pretty much done here, and just find a nice position. Okay, someplace like this. Yeah, say okay. We'll adjust the jaw a little bit. There is a little bit play between the jaw and the so you can rotate it a little bit. Okay, something like that. And if you want to, you can engage the teeth. So this part is actually not very realistic. This actually goes inside that chamber here. So this will not come out. Okay. And so it seems like at this angle the teeth will not engage. If you want to make that engage, you can disable that to distance constraint here. Distance that and this distance, and then say we want to pick some faces to touch each other to engage. So we'll pick this face. Okay, we can hide the handle first to engage maybe this face. Alright, then you look from the top. It depends on your sketch. If your part is perfectly match each other, then it should be fine. And as you can see, this position moved because of the teeth. So the locking mechanism is if this knob switch and push the left side, it'll go up. Once it go up, and it'll disengage the teeth. Okay, that's the mechanism there. And yeah, it's a little bit off. So we might be able to rotate it more, but it really doesn't matter here. I guess that's the best that we can do. You can change the engaging teeth, change some, then it'll have different positions. So I might want to move the jaw a little bit closer, not open that much. Okay. So actually when the lock engages, this angle is fixed from the handle to the link, and this way it will be a solid piece. Okay, if you analyze the motion, and once it's disengaged, this will be two pieces, and this angle will change. Okay, and this is a really complicated geometry, and you will find out when we do the simulation. So I guess that's all we need to talk about for the assembly. If you notice, we have a section here. You can build a new section. What it does is you can take a look at half of the, you can have a section view of your model. Sometimes it's pretty neat. Let's say we want normal to xy and z equals 0, and say OK, and that's the cross section of your assembly. And if you check this, it'll show the boundary lines, and that's pretty useful when you are trying to do something inside here. Okay, then if you want to turn it off, just double click, it'll turn it off. And if you want to hide the blue intersection lines, you can uncheck the box. So these are the things you can do in assembly. And by the way, if you want to modify a part, say my jaw here, I forgot to do the edge blend. So what we can do is you can right click and make a work part, which is the same, excuse me, as double click on the part. So now you're modifying this part, and you can go back to the part navigator. Then as you can see, the top we have the modeling tools. You can do edge blend. Okay, and once you're done, you can go back to the first tab, which is the assembly navigator, and double click on the assembly. That means you're working on the assembly now. So by double clicking either one of them, you'll be working on that piece. Sometimes if you feel like there's too much on the screen, you can right click and make display part. This will take you to the part, yeah, without all the other parts. So also it'll load the part in the window here. We're gonna go back to assembly. So that's how you modify a part from the assembly. And let's see what else. Yeah, there's another thing is for the project you have to make a drafting for one part, and you can choose any one, either part. Okay, I'll start from this just to give you some examples. So you can start drafting from your modeling part. You can also build a new drafting and link the drafting to this model part, which we talk about that in the class or in the lab. And we can do it here. Just start the drafting right away in the model part. Okay, now you can pick your size and the standard size. Use a template. Okay, the template will have a company logo, which is Siemens for now. Okay, the standard size is blank. There's nothing. And every time you create, probably will give you this creation wizard. So since I have all the parts loaded, now it'll ask you which one you want to make a join. And so far we picked the jaw. The next step is the options. There's really nothing to change here. So next step, which view you want to use as the base view. Okay, you can use right view or front view, top view. Okay, so stay default. Next is which views you need. So that one's good. We probably need a isometric. Looks like this view is not necessary. Just click and it'll delete that and finish. Okay, and you notice we have sketches on the screen. So if you go back to the part navigator, you have all the modeling features here, or design features. You can hide these sketches, or we have a faster way here, show and hide. You can just click on the minus sign for the sketches, and you notice this line here is actually the datum. Then we can uncheck that datum. You probably want the coordinate system, but actually I think in the drawing you don't have to. Anyway, so we can keep this. All right, so that's the base views. If you want other base view, you can insert a base view, okay, anywhere, which type. And also you can insert the projected view. The difference between these two are projected view is projected from a base view, and base view is independent of other views. So if you move this part, you can see all three of them are linked. So one of them is base view and the two of them are projected from that. Okay, and we don't really need another base view here. What I need is probably I want to see the profile in the middle of this jaw. So we have a section view here, which is required in the report. You need to have at least one section view for your drafting. So section view, as indicated on the symbol, it'll cut one piece open. So I want to cut this open in the middle. Okay, so I will pick first, select a parent view. I'll click this view. So now I'm cutting in this view, and where I'll click the midpoint of this line. Okay, so we'll cut from that point, but you want to cut like this, or you want to cut like this. Okay, probably we want to cut like this. Okay, so we look from the top, and it looks like this. And you can see the difference between the top view and this section view. Okay, it'll show the inside the profile of these faces. And we can move this to the side. It's not associated in a sense like the other projected views. Okay, so we have the views. We don't have dimension yet. And next we can import dimension because we don't want to do the dimension again here. And that's the command feature parameters. Okay, so basically we're importing parameters from a feature, and those features are the sketches. So we'll import the parameters, which is dimension, from the first sketch. And the second step, after you pick which sketch you want to import, you have to click this button to select which view you want to put those dimensions on. So we'll pick this one, and you can say OK. So luckily, my dimension in the sketch was not that bad. Okay, you can adjust them a little bit, then you're good. And if your dimension in the sketch is really messy, that's why I said you need to make your sketch dimension neat, so you don't have to adjust it too much in the drafting. Alright, so let's say I'm satisfied with this, and the only thing might be is, so say sometimes I want a fraction dimension, so you can click on this and change the style. So that is style. Once you open the style menu for dimensions, okay, you have these tabs in the units tab. You can change that to fraction, and in this dimension tab you can change the precision of the fraction. So usually you might need at least 1/32. Sometimes we use sometimes we even use the 64th. So you would have this fraction dimension. And some might ask, what if I want odd fraction for the whole thing? So I don't want to drop a dimension, change it to fraction. So you can do, you can set this global setting in preference and annotation. Alright, so here we have pretty much the same tab. If you do a style on a dimension, you have units, you can change it to a fraction. You have dimensions, you can change the precision of your dimensions, and all the other little things. Okay, so that's for the dimensions. And for the views, you also have a style menu. What it does is you can define the thickness of the lines. You can define the rendering of this view. So for example, I'm going to plot this drawing, and I want my isometric view to look like, to have color and shaded. So this shading menu, this tab you can change to fully shaded, and to apply you would have your isometric view colored shaded. Okay, so that might be a little bit easier to interpret when you have the drawing. And something special for the section view in its style menu. Okay, as you can see, we have this crosshatch indicating that is the cut portion, and this portion is actually not intersecting with our cutting line here. So sometimes we don't need that. We just need to see, okay, what was cut. So we'll do in the section tab we can uncheck the background. So pretty much means that this is behind the cutting line. That's the background of the cutting line. So if you uncheck that to apply, you wouldn't see the background. You will only see the intersection plane that's cut by the cutting line here. Okay. So what else? Yeah, I guess that's it. And if you want to plot into a image file, you can do File and Plot. Okay, so that's the path it'll save to, and you have settings to change the resolution. Even the high is not very high. So sometimes you want to have advanced plot. Okay, in this advanced plot, you can change this print setting. So as you can see, default resolution is 72 dpi, which is very pathetic. So at least 250. Even Word documents might be above 250. So you can do 250, and if you want to have really neat, maybe 300 or 600. Okay, so 300, that's, you can see the pixel is crazy now because that's the size of the picture. And you can do print. We'll save to desktop, save that into my folder here. Okay, after it's saved, let's get into this folder. That's the picture we have, and it's, if you zoom in, it's, the resolution is okay. Okay, and as you can see, the line width is not distinguished from the dimension line. It's a little bit thicker than the dimension line. If you want to change that, you can change that in the style of the views. So I think that's all for the assembly of this project. Okay, I hope you enjoy this video.